Hi guys, this is the next video, Traditional CI Servers. In the last video, we looked at SDLC and testing types. In this video, we're going to take a look at Bamboo and Jenkins. Let's start with Bamboo. Bamboo is a proprietary CI server that is developed by Atlassian. Atlassian is a software company that specializes in tools for developers. Products such as Jira and Bitbucket are created by Atlassian, and they are well known in the IT world. Bamboo is their proposal for CI activities, and it's quite popular as it integrates fairly well with their other products. Now, let's install it. In order to do that, we visit Bamboo's homepage at this link and follow the instructions in the Quick Start Guide. We click on the View Topics button under the Installing and Upgrading section. An Installing and Upgrading page will open. We have to click on the Installing Bamboo on Linux option. You can select option of your choice. It will direct us to the page where we will get a link to download Bamboo. As you can see, the installation is quite simple. After generating the evaluation license, we click on the Atlassian link on the page. It will direct us to the login page where we select Login with Google. Just add your Google account. This opens the new evaluation license page where we click on the Generate License button. Before that, we have to make sure that all the columns are filled. Here, we add the organization name. And finally, click on the Generate License button. After that, we copy the license key from this page and paste it here on this page. We then click on the Express Installation button. This will set up Bamboo on our computer. Finally, we have to click on the Finish button. Now, if we click on the button labeled Create Your First Build Plan, we can see how easy it is to set up jobs in Bamboo. In this case, we can use one of the open source projects that I created in the past called Visigoth, a load balancer with circuit breaking capabilities used for interconnecting microservices. The GitHub repository is located at this link. Fork it into your GitHub repository if you want to modify it. Visigoth is a single component that does not interact with others, so only unit tests were created for it. Now, we click on the Clone and Download button to copy the clone URL of the repository. We now move to the Configure Plan page, and in the Select the Repository Host, we select Git Repository. After that, we add the display name, username, password. Finally, click on the Configure Plan button. It will direct us to this page. Once you finish creating the plan, it will ask you to add tasks to your test plan, which at the moment is only checking out the source code from Git. In this case, Visigoth is a Node.js application, and the tests are run by executing the npm test command. In order to run the command, we need to add two tasks of the type command. Now, we click on the Add Task button and then on the command task type. It will open up the command configuration. The first task will be used to install the dependencies of the application, and the second one to run the tests. Let's add the first one. First, we will enter the task description. Next, we click on the Add New Executable and specify the name and path where npm is. For that, we will go to the terminal and type which npm. It will give us the path. Just copy the path and paste here. And then click on the Add button. We will need to install Node.js on the same machine where we installed Bamboo in order to run the tests. The current LTS version will work fine with it, but Visigoth was tested with Node 6.x. Now we will add the argument. And finally, click on the Save button. Next, we will add another task for npm test. We are adding the second command that will execute npm test in order to run the tests. We will follow the same steps as previous. Add the task description as npm test. After that, we will add the argument as well. Lastly, we click on the Save button. We have completed all the actions that we need to execute in order to run the tests in Visigoth. Next, we click on the Save and Continue button. Now, the only thing left is to run the job. If everything is correct, we should get a green badge and a message of success. We can check the logs of the job to see how many tests were successful and other useful information. If we explore this even further, we can see how Bamboo also offers different types of tasks, such as Mocha test runners, which allows Bamboo to understand the result of the tests. At the moment, with the current configuration, if any of the tests fails, Bamboo won't be able to understand which one failed. I'd suggest you to play around with different configurations and even different applications to get yourself familiar with it. As you can see by yourself, the interface is very friendly, and usually it is quite simple to achieve your desired setup by creating new tasks. By default, Bamboo creates something called Trigger. A trigger is an action that leads to a test plan being executed. In this case, if we change the GitHub repository from where the job was created, the test plan will be triggered to verify the changes, ensuring the continuous integration of new code. Another interesting type of trigger is the time-based one. This type of trigger allows us to run the build overnight. So if our tests take several minutes or even hours to run, we can do it when no one is using the server. This type of trigger has saved me from bugs derived from the daylight time savings hour adjustment, causing some tests to fail due to code fragments not handling the change across different time zones well. Bamboo can deal with every situation, and it has adapted to the modern times. We can even build Docker images and push them to remote registries once the tests have passed in order to be deployed later on. Bamboo is also able to take actions in the post-build phase. For example, alerting us if the build failed overnight with an email or other communication channels. Now we move to the next part, that is Jenkins. I've worked with Jenkins for quite a while now, and I have to say that I feel really comfortable working with it as I know it is free, open source, and also highly customizable. It has a powerful and well-documented API that enables users to automate pretty much anything related to continuous integration. Jenkins is also modular, which enables developers to write plugins to extend functionalities. For example, sending messages to a Slack channel if the build fails or running Node.js scripts as a part of a job. Jenkins can be scaled to hundreds of nodes through a master and slave configuration, so that we can add more power to our CI server in order to execute some tasks in parallel. It is also possible to write plugins for Jenkins, so virtually there is no limit to what it can do. Let's focus on the operational side of Jenkins for now. In order to run Jenkins, we have two options. The first option is running it as a Docker container, and the next option is installing it as a program in your CI server. For now, we're going to install Jenkins using its Docker image, as it is the simplest way of running it, and it fits our purpose. Let's start. The first thing is running a simple instance of Jenkins using this command. This will run Jenkins. But be aware that all the information about configuration and builds executed will be stored within the container. So if you lose the container, all the data is lost as well. To use a volume for storing the data, we run this command. It creates a volume that is reused later on when upgrading to new versions of Jenkins or even restarting the same container. After running the command, the logs will be shown like this. This is the initial password for Jenkins, and it is necessary in order to set up the instance. After a few seconds, the logs of the container will stop, which means the Jenkins server is ready to be used. Now, we open the browser and go to localhost 8080. Here, we have to enter administrator password, which we saved earlier, and then click on the Continue button. The next screen will ask whether it should install the suggested plugins or whether you want to select which plugins to install. We choose the Suggested Plugins options. After a few minutes, it will let you create a user, and that's it. Now, we enter the username, password, confirm the password, full name, and email address. And then click on Save and Finish button. Jenkins is up and running in a container. Finally, we click on the Start Using Jenkins button to get started. Now we're going to create a new job. We're going to use the same repository as we used with Bamboo so we can compare the two integration servers. Let's click on Create a New Jobs. Here we will enter the project name as Test and choose the first option, that is, Freestyle Project. Jenkins has different types of projects. Freestyle Project is a type of project where we can define the steps as we did in Bamboo. Another interesting option is the Type Pipeline, where we can define a set of steps and stages, creating a pipeline that can be saved as code. We then click on the OK button. The page is where we will configure our project. In the Source Code Management section, we will choose the Git Radio button. Here, we're going to use Git with the repository hosted at this link. We have to just paste the link here. Now, we need to install the dependencies of Visigoth with the npm install development command and execute the tests with the npm test command. But we are running Jenkins from a container, and this container does not have node.js installed. We're going to use our Docker knowledge to install it. Inspecting the Docker file of the Jenkins image in the Docker Hub, we can verify that it is based on Debian Jessie, so we can install the required software in it. The first thing that needs to be done in order to install the software is gain root access to the container. Let's run the command for that. Before that, we will check the container ID using the sudo docker ps command. Next, we will run this command. This command executes /bin/bash in the container with this ID, but with the user that matches the user ID 0, in this case, root. We need to do this because the Jenkins image defines and uses a new user called Jenkins with a known UID and GID. So if the -u0 flag is not passed, the /bin/bash command will be executed by the user Jenkins. Once we are root in the container, we proceed to install node.js. And once the execution is finished, run this command. And that's it. From now on, our Jenkins container has an installation of node.js available to run node.js scripts. Once node.js is installed, we can just exit the root shell within the container and go back to the Jenkins to complete our tasks. As we did with Bamboo, here are our tasks in order to run our tests. On this page, we go to the Build section and select Execute Shell under the App Build step. Here, we will add the command. Again, we click on the Add Build step and select the Execute Shell option. After that, we will add another command here. In the very bottom of the job configuration, there is a section called Post-Build Actions. This section allows you to execute actions once the job is finished. These actions include sending emails, adding commit messages to the Git repository, among others. Jenkins is extensible and new actions can be added by installing new plugins. Once we've added these two new steps to the build, we just click on Save button and we're all set. We now have a fully functional Jenkins job. If we run it, it should successfully run the tests on Visigoth. Now, let's see Secrets Management. One of the possibilities of the CI server is the ability to talk to third-party services that usually rely on some sort of credentials to authenticate the user. Exposing these secrets would be discouraged, as they could potentially cause major harm to our company. Jenkins handles this in a very simple way. It provides a way to store credentials in a safe way that can be injected into the build as environment variables so that we can work with them. Let's look at some examples. First, we need to create the secrets in Jenkins. We will now click on Credentials on the left-hand side. Next, we click on Jenkins and then on Global Credentials. We are using the Global Credentials store as we just want to showcase how it works, but Jenkins allows you to box credentials so that you can restrict access across different usages. In Jenkins, credentials, aside from being injected into the build context, can be connected to plugins and extensions so that they can authenticate against third-party systems. Now, we click on Add Credentials on the left-hand side. There are some fields that we will need to fill before proceeding, but they're very basic. The first one is kind, which is the type of secret we want to create. If you open the drop-down, there are several types, from files to certificates, walking through usernames and passwords. Scope defines the scope of our secret. The documentation is not 100% clear, but it allows us to hide the secret from certain stances. There are two options present here: global and system. With global, the credentials can be exposed to any object within Jenkins and its child, whereas with system, the credentials can be exposed only to Jenkins and its nodes. The rest of the fields are dependent on the type of secret. For now on, we're going to create a username with password secret. Just select it in the drop-down and fill in the rest of the details. Once it is created, it should show in the list of credentials. The next step is to create a job that is bound to those credentials so we can use them. To create a new Freestyle project, just click on the new item on the left-hand side. Now we will enter the project name here and click on the OK button. In the Build Environment section, we select the Use Secret Text or File. Next, in the Binding section, we click on Add drop-down menu and select Username and Password conjoined. Conjoined username and password means that we get the full secret in a single variable, whereas with separated, we get the secret split into two variables, one for the username and another one for the password. Once we select it, the form to create the binding is fairly simple. We get to choose the variable where we want to store the secret, and we also get to choose which secret. There is a radio button that lets you choose between parameter expression or specific credentials, as we can parameterize the job to get input from the user on the triggering screen. In order to showcase how well thought Jenkins is, we're going to add a build step that uses the secret by just echoing it into the logs. In the build section, we add the command. After that, we click on the Save button to save the job and run it. Once the job execution finishes, go to the result and click on Console Output. If you were expecting to see the secret in here, Jenkins has a surprise for you. The secret has been masked in order to prevent exposure to unauthorized users. This is not bulletproof, as someone could easily dump the secret from a test within an application checked out by Jenkins. But it adds some level of security in there, leaving the rest to the code reviews and processes. In this video, we've looked at traditional CI servers. In the next video, we will see modern CI servers.